Okay, question 2M5 from second edition of Statistical Rethinking. The previous question, question 2M4, asked us to consider a situation where we had three different playing cards. Okay. One of them had two white sides. One of them had a white side and a black side. And the other one had two black sides. Okay. And then we were to put these into a bag, draw one randomly with our eyes closed, put it on the table, and notice a side, and notice that the face-up side of the card that we pulled out was black. And then we were asked to consider what is the probability that this second card here was, or that the second side was also black. In other words, what was the probability that it was this card right here? Okay. And in that video, we decided that the way to go about this, so if we wanted to figure out the probability that the card that we had drawn was in fact black, black, given that we had observed black, that the way we were going to solve this was to first find is to plug it into Bayes' theorem. And so we first would find the likelihood, which was what is the probability that the side that was facing up was black, given the hypothesis that the card we drew was black, black, okay, times the prior probability of drawing the black, black card. And then all of that divided by the marginal probability, which is the probability of drawing, of having a card that was face up having black. And so we figured that the best way to do that was to count how many sides we could have seen. And so there was three cards, each with two sides, and 1, 2, 3 of those sides was black. Okay. And so when we went through, so we just said that 3 of the 6 sides were black, so we figured out that this probability down here was 1/2. The probability of drawing the black, black card, well, there's 3 cards, and so we drew 1, so that was just simply 1 out of 3. And now the probability of a black side being face up, given that we drew black, black, well, then that's just 100%, that's just 1. And then we found out that when we did this math, the probability, the posterior probability of black, black, given that we had seen black, was 2/3. Okay. So this problem asks us to consider a similar situation, but now we have, instead of 3 cards, we have 4 cards. And this 4th card is also black, black. Okay. And again, so plus this. So again, we draw a card, we put it on the table, we notice that the face we can see is black, and so we're asked the same question again. What is the probability that, that the other side is black? Or in other words, what is the probability that we've drawn one of the 2 black, black cards? Okay, so let's use a different color. So we're just going to go back through and put this into Bayes' theorem again. So now we have the probability of black, black, given that we've observed black. Okay. All right. Just copying this down from above, and we'll try to figure out what the values are. Okay. Okay. So again, the likelihood of a black side being face up, given that we've drawn one of the black cards. Okay, well, this is just 1 again. Okay, but now the prior has changed, right? The probability of black, black is no longer 1 out of 3. It's 2 and 4, or 1/2. Okay, so that has changed. And now the probability of drawing a black is no longer 1/2. So now we have 8 sides, 4 cards with 2 sides, but now 1, 2, 3, 4, 5 of those sides are black. And so this becomes 5/8. Okay. So if we do this math, so we have 1/2 divided by 5/8. So we can say 1/2 times 8/5. That becomes 8/10/4/5. And 4/5 equals 80%.